So you'll notice that if you're in the classroom here, I did pass out our Module 1 assignment on spur gear design, Chapter 9. And these problem numbers are going to correspond to the problem section at the end of the chapter. So I've picked out some, and what I want to do is I want to go over these right now so you understand really what I'm expecting for each one, and then you can ask any questions, and then you'll have time to work on them to complete them and possibly get them handed in. So I'm opened up to page 423. And that's where the problems, start for this at the bottom of this first page. So we are assigned 9-1, and I'm gonna scooch over here a little bit, zoom in. And you'll notice that I picked out A, B, C, D, E, and then G. Okay, so the ones that you're responsible for are only those letters. So it says we have a pair of spur gears that are 20-degree pressure angle, full depth involute tooth, transmits 7.5 horsepower. The pinion is mounted on the shaft of an electric motor operating at 1750 RPM. The pinion has 20 teeth and a diametral pitch of 12, and the gear has 72 teeth. So they want you to compute the rotational speed of the gear, the velocity ratio of the gear, and then pitch diameter of both the pinion and the gear, center distance, pitch line speed, but then skip F, and then G is going to be that tangential force, and then you don't need to do H and I. So as you can imagine, there's a statement here at the bottom. Use your spreadsheet whenever you can. So if we go back to our spreadsheet here, you'll notice that there's spots for you to input this information. Now, it's not exactly the same as this. So what you can do is you can put your horsepower in, your input speed, your diametral pitch, the number of teeth on your pinion, and you can skip down to then the number of teeth on your gear, okay? And then what'll happen is it'll populate this area, which corresponds to what it's asking for. Now, to get the points for this assignment, it's not just about putting them in and I'm done and taking a screenshot. Now tell me, of these results, where is A? Where's B? Where's C? Okay, tell me where each one is. And I would expect that in the column over here, you would list each one of those letters wherever it would be corresponding or applicable. Okay, so make sure that you're answering the question. So for this one, you could zoom out so that you would just see, kind of this portion right here, and then you would do a screenshot to include all of that and then show me the labels of what the question is asking for, okay? Yes, 9-1 is almost identical. Yeah, actually. Perfect. Yes. Yes. So example 9-1 is just like this. Yep. Make sure that we label them. Cool. Good, good, good. So you guys did that as a practice problem, you're saying, right? Yeah. All right. So then turning the page, we're going to go to 9-8. So 9-8, 9-8, 10, and 11. Those are all right here. Second column on page 424, it says specify a suitable quality number. Those are those AV numbers for gears in a drive for a grain harvester. So you're going to go and you're going to find the chart where it gives us the categories, and then it tells you what an appropriate AV number would be, or that quality number. It might not be exactly these, but you want to try to line it up with something that's there. The next one is going to be for an automotive transmission. And then the last one is going to be for a gyroscope on a spacecraft, I guess. Okay. So those three, you just need the quality number. You just need the quality number for me. So AV is equal to. Then we're going to go over to 17, 21, and 26. So 17 starts on the bottom of that same column. Gear materials, it says, identify the two major types of stresses that are created in gear teeth as they transmit power. Describe how the stresses are produced and where the maximum values of such stresses are expected to occur. Okay, we did talk about two main ones over and over again the last couple times we were together. So answer that question, okay, and make sure you're complete. I always look back and I say, did they identify the two major stresses? And then did you describe how those stresses are produced and where they're going to be maximum? Okay, so make sure that you're identifying each one of those in your answer. Then we're going to go up to number 21. Number 21 says, describe the general nature of the differences among the types of steel, grade 1, grade 2, and grade 3. This requires you to go to that section about gear materials and find what each one of those means. We didn't talk specifically about it, but that's why I have it here. Okay, so you gotta put your nose in the book and find that. Then the next one, number 26, it has all parts A through G. So 26 is multi-part, and you want to do all the parts. And it says determine the allowable bending stress number and the allowable contact number for the following materials. If you have a through hardened grade 1 steel that has a hardness level of 200 HB. So we're going to go back to those charts on page, I think it was 390. Yeah, 390 is the bending. 391 is the contact stress. So what you're going to do is you're going to kind of read this backwards. Here are the HB numbers on this axis. You're going to go up to the corresponding grade line, and then you're going to read over what the corresponding allowable bending stress number is. And you can read it in KSI. That's totally fine. Okay, so it's just kind of practice making sure you understand how to read that chart. And you're going to do that for all parts of number 26. Okay. And notice that you need a contact stress number and a bending stress number. So you're going to do one for the bottom of that first page and then for the top of the next page. So each one of these is going to have 2 answers. Okay. Now, the last 4 go together. The last 4 go together. So 36, 42, 48, and 54. Okay. They're kind of like a continuation problem, like how we did our examples, through the chapter. So let's go to number 36 to start. So on page 425, second column, for problems 36 through 41, we're going to compute the bending stress number. Okay. And that's just the first one without any of those extra factors. Okay. Without the X's the Y and the Z factors. And what you're going to do is they're giving you this information. We have a pair of gears, 20 degree, full depth involute tooth, 10 horsepower. And we have a pinion is going to rotate at 1750 RPMs. The diametral pitch is 12. The quality number is A11. The pinion is 18 teeth. The gear has 85 teeth. So they're giving you that information. Okay, so you kind of got to manipulate the top there. The face width is 1 1/4. The input power is from an electric motor, and the drive is to an industrial conveyor. So that's going to help you with your overload factor. The drive is to be a commercially enclosed gear unit. Okay, commercially enclosed gear unit. So that's the first part, and that's just the bending stress number. So you need to label number 36, and that's going to be for both the gear and the pinion. You're going to label where that is on the spreadsheet. Okay, it's down here. Okay, these are your options, right? Then we're going to turn the page. We're going to go to number 42. 42 is a continuation of problem number 36. So you're going to keep the information from 36 in there. Yes. I do want to see what you have filled in. Yeah. So like for number 36, you would want to capture the top. Well, really you could say for all 3 of these or all 4 of these, capture the top maybe in 1 or 2 screenshots. And then at the bottom, you could say, okay, this is number 36, number, So it might be 2 or 3. But then at the very end, like you could have these all filled out and you're going to show me where 36 is, where 42 is, where 48 is, and 54. Okay. So this one is a continuation. Use the data from 36. And what you're going to do is you're going to do the required allowable bending stress number. So now the information up here, they're telling you that the safety factor is going to be 1. And then they also tell you that your reliability is going to be 0.99. So then you're going to use that number to get your KR factor, that reliability factor. And they're giving you the design life now of 20,000 hours. Okay. So you're gonna have to look, do I need a Y and a Z factor for bending? All right, and you probably are, okay? So then you have to fill that out. And then you're gonna label number 42. Then you're gonna go down to number 48. And notice here that you're gonna continue on. And now this is gonna be your pitting resistance number. And so you need to label number 48 among those bottom values for the stresses, which ones correspond to just the regular pitting stress. And then number 54 goes to the top of the next column. And now you're going to use that data from the previous, but down here at the bottom, it starts kind of telling you, now you're going to use those very same number of hours here from the bending. And now you're going to see, do I need an adjusted value for my pitting stress? Okay. For my pitting stress. Now, at the end here, you have to see what your stresses are. If your stresses are too high to get hardened, then you're going to have to go back up to the top. And even though they said that you're using diametral pitch of 12 and 36, if they don't fall on the charts that you can harden those, if they're too high, then you're going to have to go back and you're going to have to adjust that diametral pitch to be something that's going to be more usable. You can keep the number of teeth on there. I'm not going to worry about that. You can keep the number of teeth, but you're going to have to adjust your diametral pitch. Okay. If you need to. I don't know if you do. I honestly don't remember. It's been a year since I did this. So I would have taught this last year. So that's why I say that. Okay. But you can keep the same number of teeth. Diametral pitch you may have to change to bring that stress down. Okay. You could change the face width as well. Yes. Any other questions? Okay. So that's the assignment. I'm going to just look virtually. Does anybody virtually have any questions? Okay. All right. Okay. So you've got practice problems to hand in. You've got now the assignment that you can work on. The rest of the time that we're together here, so we're here until about 10 to 4. I'll be available to answer any questions. So, so you can work on getting this assignment done. Okay.
Those aren't out of our keep the diametrical pitch.
You could, yes, yes. Okay, back up here. I'm going to stop.